children, how are you all? I hope all of you are fine. And today we are going to start our physics class, okay? And my name is Sudeshna Mukhopadhyay. I'll be taking your physics classes each and every week. I'll be sending you one video, and at the end of the video I'll be giving you a little bit of homework, okay, and so that I'll understand that you have understood or not. Okay, it's very important that I need to know that you have understood or not. So let's begin. Okay, all the best. Let's begin with the first chapter of physics of class 9, that is motion. Okay, so when I say motion, what comes in your mind? A car moving. Okay, I'm not good at drawing, but a car that is moving. Okay, or a plane, right? A plane flying. Okay, a plane flying high. Okay, so a car moving, that is in motion. A plane flying, that is also in motion. Okay, now if I look in all these points, I can see that anything that is moving is in motion, right? Now suppose I am going, I have took a bus, okay, and I want to go somewhere, and I'm sitting in the bus. Okay, now the bus is moving, I'm sitting in the bus. Will I call that I am in motion? Think about it. Okay, or suppose both the buses are moving together, okay, in the same speed, and you are seeing that from one window of the bus you are seeing your friend sitting in the other window of another bus, and both the buses are moving in same direction. So can I say that both are in motion? Okay, so let's see what is motion. In this chapter we will see that what is actually the definition of motion, and what are the terms, what are the different types of motion, and all these things we are going to see. So let's proceed. So to describe motion, we have to think about something. Okay, we have to know something, that is, motion is a phenomenon in which object changes its position over time. Now see, what does the word phenomenon mean? Phenomenon means change. Okay, motion is a phenomenon in which object changes its position over time means, suppose an object is in point A. Okay, suppose here one object is standing, and suppose it shifted its position to B. That means it is the change, okay, with time, and it took, suppose certain time it took. Suppose like real life example, if I give you, like at 8:30 you reach to school, right? And again after reaching to the school gate, you move over a certain distance and you reach to your classroom. Okay, that means what? You are changing your position over time. Okay, from 8:30 to 8:31, what you're doing, suppose at 8:30 if you're standing in the school gate, then 8:30, by 8:31 you're reaching to your classroom. So that means with the time, over time, you're changing your position. Okay, second thing, motion of a body is observed by attaching a frame of reference to an observer and measuring the change in position of body. Now this one, it's so big sentence, you might be thinking what is it. Now see, it's very easy thing. Okay, the example that I have told you beforehand, that suppose I am traveling in a bus, okay, and the bus is moving, okay, and I am sitting in the bus. Okay, so when I am seeing an object outside the bus, okay, that means with reference to that object, that is, if I am sitting in the bus, if I am passing by a tree, okay, or a hut, or a building, or RMZ Galleria Mall, whatever it is, okay, if I am passing by any of the object that is situated outside the bus, then with respect to that object I am in motion. But if in the same bus, if your friend is traveling with you, okay, he is sitting just beside you, with respect to your friend you are not in motion, right? Your friend, you seeing that you are in the same position for a long time. Suppose you boarded the bus at 7:05, okay, 7 o'clock in the morning, okay, and by 7:15 he is seeing that you are still on the same seat, same place, you have not moved a bit also, you are sitting in the same place. Then with respect to your friend you are not in motion, but with respect to the place from where you got up to each and every object that the bus is passing through, you are, with respect to that you are in motion. That means the object with which we are comparing our movement, that is known as frame of reference, okay, that is known as frame of reference. Okay, now third point, mathematically motion can be described by distance, displacement, velocity, speed, time and acceleration. So motion, now if I want to describe motion, how will I describe motion? Of course motion means it will have some speed, no? That means what? It will cover some distance or some displacement, or with respect to time, with respect to the change in speed. Suppose here in the road was little crowded, so it was going slowly, then it took a speed and it is moving. So with respect to all these things we can describe motion. So I am telling the points again. Motion is a phenomenon in which object changes its position over time. That means it's a change of a body with respect to time, okay, with time. At one time if I see a body in one place and then it changes its position again, then it is in motion. Secondly, motion can be described with observed by attaching a frame of reference of an observer and measuring the change of the position of a body. Remember the example of the bus that I given you. The bus is moving, you and your friend boarded onto the bus, and with respect to your friend you are not moving. Okay, bus is moving, but with respect to your friend you are not moving. But if you compare yourself with the place from where you boarded onto the bus, with respect to that you are in motion. Okay, and third one is motion can be described by distance, displacement, velocity, speed, time and acceleration. Okay, note it down. Now let's see how many types of motion are there. So motion is of two types. Okay, one is uniform motion and the other is non-uniform motion. So motion is of two types, one is uniform motion and another is non-uniform motion. Now what is the meaning of uniform and non-uniform? It's not the uniform that you are wearing to school, okay, that is also known as uniform, but here uniform means it will cover same speed, it will cover same distance, okay, means it will be, there will be no change in this speed, okay. And non-uniform motion means where in motion the body is moving with different speed, okay, that is it covers unequal distance in time, okay. So this is known as non-uniform motion. Like for example, I can give you, suppose if you take 15 minutes to come to school, because you'll be in a hurry, no, you will be late to school. So if you take 15 minutes to come to school, now while returning you may stand and talk with your friend, and you may decrease your speed, sometimes increase your speed of walking, okay. So that type of motion is known as non-uniform motion. Understood? Okay. So if I tell you to describe uniform motion, what will you see? What are the points that will, how can you judge that a motion is uniform motion or a non-uniform motion? Okay. The first thing is that object will move with a constant speed. Okay, the speed will remain constant. That means it will not stop. Okay, it will have a speed. Suppose it is moving in 40 km/h, then till reaching the end of its journey, it will move with that speed only. That means speed will not change. Speed will not change. Okay. Second thing is that it will move in a particular direction. That is, it will not change its direction. Okay. Suppose a body is moving in north, then it cannot change its direction, but the speed is remaining same, but it is moving in the southward direction. It cannot happen. Okay. It will have to move in a, if it is moving in north direction, then it will have to move in north direction. If it is moving in south direction, it have to move in south direction. Okay. Whatever direction it is following, it has to move in that direction only. And regular interval of time, the time interval, that should be regular. Once it is moving 5 minutes, once it is covering in 10 minutes, no, that cannot happen. So these are the 3 points that you should keep in mind while judging uniform motion. One is object will move with constant speed. The second is it will have to be moving in a particular direction, and third one, it will have to move in a regular interval of time. Okay. Now see, let's describe non-uniform motion. Here non-uniform motion means what? The body will travel different distance in equal interval of time. That means the time interval or the time taken by the body to move from one place to another, time that is we are calculating, that time will not change, but the distance covered will change. Okay, that means what is changing? Actually the speed is changing. Okay, so that means its speed will, sometimes it will go slow, sometimes it will move fast. If this type of motion you are seeing, that is known as non-uniform motion. So here again, I'm not good at drawing, but it is understandable, no? See, I have tried to draw a car. Okay, and here you see the car is in 1 second, it has covered suppose 4 meters. Okay, in this next 1 second, next 1 second it has covered maybe 6 meters. That means what? First it has covered, it has taken less, means its speed was much more because it has covered, its speed was much less, so it has covered only 4 meters. But again in next 1 second it has covered 6 meters, which means it has increased its speed. Now suppose it has covered in the next 1 second, it has covered only 2 meters. That means what? Its speed has decreased again. So once increasing, once decreasing. This type of motion which do not have equal cover of equal distance, but the time interval is same, those type of motion is known as non-uniform motion. Now let me tell you a story about two brothers. Okay, let me tell you a story about two brothers, Ram and Shyam. Okay, they are very good at heart, but Ram is good and Shyam is little bit of naughty. Okay, so suppose their school is over here. Okay, and their house is over here, and here is a park, and here is a shop. Okay, now the Shyam, he comes out of the house, he plays in the park, he goes to the shop, and then he reaches school. Okay, but Sham is a good boy. He takes another route. Okay, and he directly from the house he goes to the school. Okay, so this distance is covered by Ram. Okay, this distance is covered by Ram, and this distance is covered by Sham. Okay, Sham covers this distance and Ram covers this distance. Okay, from here only you can see that both Ram and Sham, for them both the initial position is the house and the final destination is the school. Okay, so from house to school Sham has taken a longer route, right, while Ram has taken a shortest route. See, so but it is straight towards, suppose if I say north. Okay, school is in the northern direction, then from the house he has taken the road which is straight north to the school. Okay, so we can say that Ram and Sham, the path covered by Sham is known as distance, whereas path covered by Ram is known as displacement. What is the difference between distance and displacement? Distance means it is the path covered by an object, that is known as distance, and displacement means, when we are talking about displacement, we say it as in terms of initial and final position. Okay, initial and final position. That means the shortest distance covered by an object between its initial position and final position is known as displacement. Understood? Here we can say that distance means total movement of a body, means from initial position to the final position, however the body has moved. Okay, the total movement of the body is taken, or the total path covered by an object. Okay, and third point is that regardless of direction, in whichever direction it goes, it is not seen. Okay, in whichever direction it may move, but it has to reach the final position. That is the meaning of distance. To make it clear, I can say that suppose A is the position of an object, okay, and C is the final destination. If a body moves from A to B, then from B to C, okay, then the path covered distance will be equal to AB plus BC. Okay, AB plus BC. Understood? Please note it down. Now see children, now I have come, after distance I have come to the second one, that is displacement. Now what is the difference between distance and displacement? Let's see. Distance means also change in position. The first point that describes displacement is change in position. Okay, not only this, you see, change in position means what? Suppose you are staying at a particular point and you move to another point. That means there is a change in your position, so which means you have covered a certain amount of track. Okay, so means your changing your position means you are covering distance, okay, or displacement. Not only that, displacement, then what is the difference between distance and displacement? Let's see. It has a direction. Okay, it will always have a direction, and as you all know that things which have which can be described by the magnitude as well as its direction, those are known as vector quantities. Okay, things which are used to describe with magnitude and direction are known as vector quantities. Okay, so for displacement, this is the basic difference between distance and displacement, that in distance we do not require to check whether it is going in which particular direction, but in displacement it is always necessary to specify the direction. Okay, third point is what? It is the shortest distance covered between initial and final position. Okay, suppose A is my initial position and C is my final position. Okay, and here I have made another point. I can reach C by two ways, either by going to B and from B to C. Suppose this is 4 meters, this is 3 meters. Okay, so I can travel 4 meters, 3 meters, and then I can reach C, or I can straight away go there. Okay, and suppose this is 5 meters. Okay, so here what will be my distance? Distance will be 4 plus 3, which means 7 meters, but displacement will be 5 meters. Okay, as you see, this is the shortest distance between A and C. If I go by this way, it will take 7 meters. Compared to that, this is the shortest. So, displacement is the shortest distance covered between final and initial position. Secondly, it will have a direction. Okay, please note down. Now, let's come again back to distance and displacement. Suppose a boy is moving in a circular path. Okay? The boy is moving in a circular path. This is the initial position, and suppose this is the final position also. Okay, so if he covers the circular path, that means when he comes to the initial position again, suppose there is a match and he has to cover the whole circular path. That means the whole playground let the playground be a circle, and he has to cover the whole circular path. And he comes back to its initial position. Then what will be its distance? Suppose this is the center and the radius is suppose 5. Okay, 5 meter. So what will be the distance? Distance covered will be equal to the track he completed. Okay, the track he just passed. Okay, that one. Now what is this track? This is a circle. So the track he completed is the circumference of the circle. And what is circumference of the circle? We know 2 pi r. So which means 2 into 22 by 7 into r is over here 5. So 5. Okay. So it will be 220 by 7. Whereas if we are talking about displacement, okay, if we are talking about displacement, then what can be the displacement? What I told you, it's the change in position from its initial position to the final position. Now initial position is this, then final position is also this. So initial and final position, what is the difference between both the points? 0. So displacement in this case will be 0. So if the boy covers a circular path, or if an object covers a circular path, then the displacement will be 0. But distance can never be 0. So from here we can conclude that even if displacement can be 0, distance can never be 0. And also one thing, suppose a boy is moving in northward direction. Okay, he covered 4 kilometers. Okay, and in north direction. Okay, and then he is coming to the southward direction, 2 kilometers. Okay, now as he is moving in north direction, he is changing his direction and moving to the south, which means distance can be negative also, because opposite direction, so it can be negative also. We can conclude that distance will always be positive and displacement can be positive, negative as well as zero also. Let's focus on scalar quantity. Okay? What is a scalar quantity? Now see, scalar quantity means which will have magnitude. Okay, which will have magnitude and no direction. Okay. Okay, if I say suppose I know to ride a cycle. Okay, you all know to ride cycles, no, bicycles. Suppose if I say I can, my speed of my cycle is 10 meter per second. Okay, suppose if I say, okay, so that what will be that speed if I am talking? That will be a scalar quantity. Okay, it will have only magnitude and it will not specify any direction. Okay, so let's see what are its example. Examples are like speed, volume, mass, okay, etc. Now speed, volume, mass are not having any direction of, we do not say, we just say it's, we just describe in a number, right? So it's a scalar quantity. So what is a scalar quantity? Which will have magnitude and no direction. Other hand, if I am speaking about vector quantity, okay, if I am speaking about vector quantity, how will I define that? It will have, of course, magnitude and it will have a direction. It will have a magnitude and it will have a direction. So what are its examples? Let's see. Examples are like velocity, force, okay, velocity, force, acceleration, so this is the difference between scalar and a vector quantity, that it will vector quantities will have magnitude as well as a direction. Suppose if I say velocity of a car is, speed of a car can be 4 km per hour, okay, like that. But when I say velocity, it is not just 4 km per hour, but it will be 4 km per hour in a particular direction, like north, south, okay, upward, downward, whatever it is, okay, like that. It should have a specific direction. So thus we come to the end of today's lesson. At the end, as I told you, I will be giving you a few questions. So take down these questions. This is for your assignment 1. So the first question is define motion. You have to define what is a motion. Second is describe the type of motion if a boy covers 5 meters in every 2 seconds. In every 2 seconds, the boy is moving 5 meters. Second question, if he covers 5 meters in 2 seconds and 2 meters in next 2 seconds. You have to just mention the type of motion. Okay. Third one states that Ram is, suppose a boy named Ram runs in a circular track of radius 15 meter. Okay. Suppose a track is there of radius 15 meter and Ram is running in the track, and what will be his distance and displacement covered if he completes one full rotation starting from A and completing in A. Suppose he starts from A, okay, and he moves and ends in A. Okay, what will be its Ram's distance covered and displacement covered? Okay, you have to state that. And the second is starting from A and completing one rotation and ending in B, which means he will be starting from A and then he will be moving. He will be not stopping in A again, he will be stopping in B. So one rotation and then stopping in B. Okay, what will be his distance and the displacement covered? So that's all for today's class. We'll be back with another video in the next week.